Morning, everybody. So today we're going to start a new topic. We're going to start looking at fractions. Now, we've done fractions before. We did some last year. So we're going to have a little bit of a recap today before we move on to something a little bit different. So to begin with, I'm going to just show you a bit of what we're going to learn this unit. So we're going to be simplifying, comparing, adding and subtracting and doing problems. And then we've got lots of vocabulary that we're going to need to use. Now today we're going to be looking at some fractions and we're going to need the word numerator, which is the fraction at the top, and the denominator, which is the number at the bottom. We're also going to be looking at the word equivalent with some of the work that we're doing. So they're the main pieces of vocabulary that we're going to need for today's session. Okay, so let's take a look at our Discover. So we've got 4 children here and they are designing some flags. And they've drawn some flags with different patterns and shapes. And what we've got to look at is think which fractions that they've drawn are equivalent. Now, what does the word equivalent mean? So equivalent means the same as, so fractions which are the same as each other. So if we take a look at the flags that they have drawn, we can see that they have got different amounts shaded inside their flag. So we can see that Rena has got one part that's red, one part that's white. So she's shaded half of her flag. Richard, his is divided into 4, so quarters, and 2 are shaded. Louis, his is divided into 3 and he's shaded 2. And Emma has decided to chop hers into 8 and she has shaded 4. Now they're all going to be different fractions, but if we look at it without thinking about all the parts it's divided into, we can see that really, I think that Rena, this flag here, so Rena's flag, Richard's flag, and Emma's flag have in fact all shaded half of the amount of their flag. You can see that if you imagine the blue part here had moved over, that would be half of the flag. So we're going to look at which fractions are equivalent and also which fraction is the odd one out. So let's take a look here. So like I was telling you, we've got the red one here that is half is shaded. You've got the orange one, which has 2 quarters, 2 out of the 4. And then you've got the blue one, which has 4 eighths, 4 out of the 8. Now, the line on a fraction, I think it's really important to remember, means out of. So you can see with this one here, we've got 4 out of the 8 are shaded in, all right? So it means out of. It's a good one to remember that. Now, you can see that you can multiply the numerators and denominators to find equivalent fractions. This red one here, if we started with a half, if we multiply the top, the numerator, by 2 and multiply the denominator, which is at the bottom, by 2, you're going to get a result of 2 quarters, which means that those 2 fractions are equivalent, or they are the same amount has been shaded in. On the other hand, you can go the other way. So you can see that the one that was shaded in the blue here had 4 eighths shaded. Now we've divided by 2 to the numerator, and we've divided the denominator by 2. And we've got an answer of 2 quarters, which we already know is the same as a half. That means all of those flags are equivalent. A really important part to remember is whatever you do top of your fraction, you have to do the same to the bottom and vice versa. You can never say, right, I'm going to times the top by 2 and then multiply the bottom by 3. You have to be fair and it has to be equal. You have to be the same to both sides. So there they are. The equivalent fractions are a half, 2 quarters, and 4 eighths. Now here is the odd one out, 2/3. Now the next question said, can you draw some other fractions which would be equivalent to this one? So this at the moment has got 2 out of 3 shaded in. Now here, this boy here has decided to draw a line down the middle. So it's almost like he split this original one in half here. So instead of just having 3 rectangles, he's now got 1, 2, 3, 4, 5, 6. So now how many of the 6 are shaded? We've got 4 out of the 6, and we could decide that just by doing a calculation. So we could say 2/3, if I multiply the top by 2, multiply the bottom by 2, I get 4/6. So that is the equivalent to 2/3. Now this girl here has said you don't always just have to double to find equivalent. You don't just have to multiply by 2. And you can see that this time she's decided to multiply the numerator and the denominator by 3. And she's gone from 2/3 to 6/9. And you can see how she's split this flag differently. She's done 2 lines. So we've now got 1, 2, 3. Sorry, let me put those spots on. 3, 4, 5, 6, 7, 8, 9 squares, and we can see that 6 out of the 9 are shaded, and we've calculated that already from doing this just here. Okay, so let's have a look at the think together. Now, this is the kind of style of questions you're going to have to do by yourself. So this one is showing a flag that has got some shading on it, and we can see that 1/3. So we know the denominator is how many squares there are altogether. The numerator is how many are shaded in. So we've got 1 out of the 3 shaded. Now you can see that this one has now been split into 6. How many out of the 6 now are shaded? We can see that there's 2. So we could have actually multiplied both by 2. All right, have a go at this one. Pause the video and do this one in a similar way. What has this one changed to? This was 6 out of the 18 shaded. How many are shaded here? Have a pause and see how you get on. Okay, so hopefully you can see that the denominator, the number at the bottom, 1, 2, 3, 4, 5, 6, is 6 because they have got 6 rectangles now. Okay, and how many are shaded? We've got 2 out of the 6 have been shaded. Now you can also see that, like we did earlier, what have I divided 18 by to get to 6? I have actually divided that by 3. And the same here, this has been divided also by 3. So that's showing us another way, if you can't do it with a picture, that you can see your equivalent fraction. Okay, now we've been having a look at questions, and I've been telling you that the denominator, so the number at the bottom, tells you how many squares you will find inside your shape. Now I can already see that this first one says I've got to design flags and shade in 4/5 of this shape here. Now already I can think, well, there aren't 5 squares inside of there. There's actually a lot more. So what do I do? What does it mean? How am I going to shade in 4/5 if I've got more than 4 squares inside? Now what I'm going to do is I'm going to think, right, I'm going to count how many squares there are actually there. So I can see 1, 2, 3, 4, 5. Right, they're going down in 5. So I've got 5, 10, 15. So I'm going to write down here 15. Okay. Now, because that's how many squares are there, that's my denominator, the number at the bottom of my fraction. Now the question is asking me to shade in 4/5. Sorry, I'm a bit slow, it's a bit tricky with this pen. Now, 4/5. So what I have to do is think, what equivalent fraction can I find of 4/5? And then if I can find that, I know how many squares to shade. So I go to here and I think, right, what have I multiplied 5 by to get to 15? I've times it by 3 because 3 times 5 is 15. Now, if you remember a little earlier, I said with fractions, you have to do the same to the top that you do to the bottom. So here I've times the bottom by 3. So what am I going to times the top by? I'm going to times it by 3. So if I do 4 and I multiply it by 3, what am I going to get? I'm going to get 12. So I can write in here that 4/5 is equivalent or same as 12/15. So don't be caught out if you've got a shape that has got different number of squares to what you're looking at your denominator. So here, if I was doing this, I would have to shade in 12 of these squares. I'm just going to do a line. It's not happy with my pointer today. So there's 5, 6, 7, 8, 9, 10, 11, 12. So now I know that's how I can define my flag, because I've shaded in 12 squares. So let's take a look at the next one. Maybe have a pause and see if you can work this one out before I explain it. So here again, it's asking for 4/5, but this time 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. So I'm going to do it over here this time, and I'm going to put my 10 because I know the number of squares is the denominator. Now, what have I times it by here? I've times it by 2, because 10 is 2 times bigger than 5. So if I've times this by 2, what have I got to multiply 4 by? I've got to multiply by 2, which will give me 8. But this time I would have to shade in 8 squareds in order to show 4/5. Okay. All right, now this again is another practice of finding the equivalent. So like I did on the previous slide, you can use the numbers that you're given to help you. So for part A, 4/12, you can see, well, what have I done from 4 to get from 4 to 2? It's actually getting smaller, so I'm obviously dividing this time. And I've done 4 divided by 2. So here I would have to do 12 divided by 2, so half of 12, which is 6. So 4/12 would be the same as 2/6. Now on this side, I can see that I've got the one on the other side completed. So here, 2 to 10, that's how many times bigger is that getting? It's getting 5 times bigger. If I go from 10 to 2, it's 5 times smaller. So I want to go this way, so I've got to do the same. And here, what am I going to do? I'm going to divide. Oh, sorry, my pen's not being very good. I'm dividing by 5. So 25 divided by 5 is 5. Now, this one's a little bit tricky, isn't it? Because it's got the denominator on this side and the numerator on this side, but nothing else. So I've got to use a bit of my common sense, I suppose, really, because I've got to see that this is a 2. Now, I could make this smaller. So if I halved it, I could make it a 1, couldn't I? So half of it divided by 2. So what would I halve here to divide by 2? I could have a 10, couldn't I? So I could have 2/10 is the same as 1/5. You might find that there are other ones. I could go the other way. Sorry, let me try and, I don't know why this is happening here. There we go. So 2/10 is the same as 1/5. Now you will find that some of these, you might find other alternatives that work as well. And as long as you're doing the same to the top and the bottom, then your answers should be okay. All right, so here is your work for today. This is what I'll have sent you on Class Dojo, but I thought in case you have any problems reading it from there, you could always pause this screen if it's easier to look at. Now, very much like we've done today, you're going to be looking at the equivalent fractions. So you're matching to start with to see which ones work. On part B, you've got to draw some lines to show the different fraction equivalents to 2/3, like we did earlier on in this slideshow. So you're going to have to draw some on. You might be looking at 6 and 9ths and all of those kind of things. Now you've got to do some shading. Now I've put a little top tip here, and it's like we did a minute ago because it's asking you to shade a quarter, but there's more than 4 squares in there. So you've got to think about how many squares there are before you could calculate it. So read the top tip because that will help you with part C. So like always, any problems, send me a message, and I hope you get on okay. And send me some photos. Please make sure you send the photos and put them on your portfolio. I got that word out. If you can't put them on your portfolio, feel free just to send me a message through Dojo, and I still then mark that that work has been complete. All right, have a good day, and I'll see you again tomorrow. Bye-bye.